I think it'd be helpful if I walked people through the argument that I made, and like, cause I invented this doctrine at about 22, and then I formalized it at 25. But I think it'd be best if there was visuals to what I was saying with about the normalcy of pi. So let's say we want to see if pi is normal. Well, if it was normal, it'd have to satisfy certain conditions. It'd have to have every possible string, and that's the main thing we're looking for. Like, we're looking for every possible string of digits, because the other things imply this statement. Like, if it was truly random, if it was, if everything appeared with equal probability, all that stuff that goes into the definition of the normalcy of pi, this is the main thing we're looking for, every possible digit. So, like, how would an engineer solve this problem? Well, they would stop at 3 and say, I don't feel like calculating it. How would a physicist solve this problem? They would say, well, I'd get back to that. How would a mathematician solve this problem? They would start calculating the digits of pi. But as you can see, I'm calculating it linearly. I'm calculating it on a flat surface, and I'm calculating it linearly. So I would have to wait until I got to the digits of pi. Let's say I want to find the digit 333 and possibly the digits 111, and see if they both appeared in pi, both of those digits. Well, I'd have to calculate this all the way out until I saw 333, and then I would have to keep calculating it until I also saw 111. As you can see, this way of calculating the normalcy of pi is either going to take an infinite number of infinite amount of time or an infinite amount of energy to go into the calculation to check if I'm seeing if all the strings are there. And also, what if I need 333, or 111? I'd have to calculate again past the original 333 until I get to 3333. As you can see, the problem is insurmountable. The computing power, like, we physically wouldn't be able to get it. But as a physicist, I say, wait a minute, it can exist in a state of being normal and not normal until I do what? Observe it. So, what can I observe about this? I already talked about it in my video, my magnum opus, but as I can see, if I looked at that digit and I say, wait a minute, if I took his calculation and my calculation and the mathematician's calculation, I could find any string of threes. If I found another person calculating pi, I could extend my thing and find any possible string, and it goes for the same thing for the 111. It depends on where I start my calculation and reorient, or other words, conserve ontological momentum. That is key to the normalcy of pi. Conserving ontological momentum. And I already defined these things. Like, I defined a lot of this stuff privately. Like, this is a lot of my magical rambling and stuff, because I'm a magical guy. But I literally where is my missing slifer? I literally already codified conserving ontological momentum in missing slifer. Let's see, where did I put it? I remember doing it. Where did I put it, though? Because it's all over the place. Here we go. Like, you define ontology as the nature of being, properties, and relations between them. Momentum is a property of moving objects that describes both their speed and direction. So I considered metaphors as objects, and then I came up with the definition of ontological momentum: the continuity of the conditions of being as in and of themselves and with respect to each other. And then I said something about process philosophy with creativity. But that's a visualization of the argument that I was making. Like, I noticed that some people, they need to visualize their mathematics before they get it. So that I was inspired to make this video, just because, I want people to be able to see what I'm talking about. Like, you can calculate any possible digit of pi. Like, if you were doing it linearly, it would not be normal, because you would never be able to prove that you would find an infinite number of these every possible strings. Like, even if you found 333, you still have to find 3, 3, 3, 3, 5, or 3, 3, 3, 3, 6, or 3, 3, 3, 3, 9, you know? But if you reorient your trajectory, if you say, I'm going to start here, and then I'm going to go to the second point here, and then I'm going to go to the third point here, and then, you know, you can find any possible digit of pi and any possible recalculation of pi. That's important because this is a pi space. Every point is essentially a place where you can start calculating pi and also calculate a digit of pi going through that point. Like, I imagined it as a sort of omnidirectional sphere, but that's high level mathematics there. There you go. That's high level math.